Okay, the next section is 2.1. That's a pretty short one. It's about quadratic functions. So quadratic functions obviously are anything where the degree is 2. To graph them, they're always parabolas. You have general form, which is ax squared plus bx plus c. That's just if you simplify everything out. A very handy form is called standard form or vertex form. The nice thing about it is it shows you what the vertex is. So if you look at this, the vertex is always at hk. So notice it's x minus h, so whatever. So if this said x minus 2 squared plus 4, the vertex would be at 2, 4. If it said x plus 1 squared minus 3, since it says x plus 1, that'd be a negative 1, comma, if that was minus 3, negative 3. So that tells you the vertex. The A tells you whether it opens up or down. So as I said, the vertex is hk. If A is positive, it opens up, so it has a minimum point. The vertex is a minimum because it's at the bottom. If A is negative, it opens down, so it has a maximum point because the vertex is up on the top. The axis of symmetry is a line that goes right through the middle of a parabola. Like if you have a parabola that looks like this, the axis of symmetry goes right through the middle. It's always just x equals h. If you want to find an x-intercept, you put 0 in for y, which can be kind of tricky, although it's not so bad in vertex form. If you want to find a y-intercept, you put 0 in for x, which is usually the easy thing to do. That works out easier. But it's only going to have maybe one y-intercept. If we go through like this one, there's different ways to put it in one of these forms. To put it in vertex form, very common way is called completing the square. So that's the first we're going to do, completing the square. You might remember doing that in algebra. Here's the steps. First, factor out the leading coefficient from the x's and separate the constant. So that means on this one, I'm going to leave it as y equals. Notice I can take a 2. See that the leading coefficient is 2. I want to factor 2 out of both x's. So that'll be x squared. 8x divided by 2 is 4x. I'm going to leave a little space. And when I said separate the constant, that's what I mean there. We're going to put the constant outside the parentheses. So that's the first step into completing the square. Okay. Now to complete the square, we're going to take half the middle term, square it, and add it inside the parentheses. So what I'm going to do here is I'm going to come down here. I'm going to bring that 2 down. Here I'm going to bring down an x because it's always going to go there. Now this is what we were just talking about. Here's our middle coefficient is 4. Half of 4 is 2. I'm going to put plus 2 down here. So half of a positive 4 is a positive 2. I'm going to put it down here. I'm going to close those parentheses and we're going to square that. Now, if I put a 2 in there and square it, that's really a plus 4 inside of here. So took half of 4 is 2, write that down below, and then 2 squared is 4. Write that in the little blank we left. Okay. Now, we're going to multiply that constant that we just put in there. See, multiply the constant, that's the 4 we just put in there, by the leading coefficient and add the opposite outside the parentheses to balance our equation. So we have that 4. Well, everything inside the parentheses is times 2. So we really added 8 to the right side of this equation. 4 times 2 is 8. To balance that out, on the outside here, we're going to do the opposite. We're going to subtract 8. So what we did here is we took half of 4 is 2. 2 squared is 4. 4 times 2 is 8. So that's a plus 8. So out here we put a minus 8. Now if we simplify, 7 minus 8 is a negative 1. We just completed the square to put it in vertex form. Now that's handy because now, like down here, it says find the vertex. Well, the vertex is hk. That'd be a negative 2, negative 1. Remember, this is x minus h, so it's always the opposite of what's in here. So the vertex is negative 2, negative 1. The axis of symmetry. Well, the axis of symmetry we said before was x equals h. So here h is -2. So the axis of symmetry is x equals -2. Then it asks max or min. Well, the max or min is always going to be the vertex. Well, we know our vertex is here. Now, usually the way it's worded is, now first, here, notice our 2 is positive, so this one opens up. If that A out there is positive, it opens up, so this has a minimum. So this one has a minimum value of whatever the y coordinate is, -1, at the x coordinate, which is x equals -2. A lot of times that's the way they'll want it worded. It has a minimum value of -1, where at x equals -2. Then it also asks us to find f of -3, so we're going to plug -3 in there. You can plug it into our last answer or what we started with. It doesn't matter. It'll work either way. So let's say we just go ahead and plug it into our last answer. We have 2 times -3 plus 2 is a -1 squared minus 1. -1 squared is 1 times 2 is 2, so that's 2 minus 1 equals 1. Again, you could have plugged that in here in our vertex form or in the beginning in our general form. All right, same thing on this one. We want to complete the square. So first, if there's a leading coefficient, we factor it out of the x's. There's a negative here, so I'm going to take a negative out of both x's. So that'll be x squared minus 6x. I'm going to leave a little blank in here, a little space, and on the outside, I'm going to put that constant, -8. So now we're ready to complete the square. So bring down the negative, bring down an x. Now to complete the square, we take half the middle coefficient. Half of -6 is a -3. I'm going to write it down below. Half of -6 is -3. Squared is 9, so we're going to put a +9 in the parentheses. Now everything in these parentheses is times a -1, so that's really a -9. So to balance that out on the outside, we put a +9. Okay, since this was a -9, to balance it, we put a +9. -8 plus 9 is 1. Now if we find all those things, the vertex, well, the vertex is going to be HK, so 3, 1. The axis of symmetry is x equals h, so x equals 3. The max or min here, A is negative, so A is negative, so this one opens down, so it will have a max. So this one has a maximum value, maximum value is 1, the y coordinate, at x equals 3. Then if we were asked to find f of -3 again, we can put it in either equation. If we put it here, we'll have a negative times -3 minus 3 squared plus 1. Well, -3 minus 3 is a -6. Squared is 36. There's a negative out front. Plus 1 is a -35. So that's how to get it in vertex form, which is really handy for a lot of things. Another thing you can do is to find the x-intercepts. So the x-intercepts is where it crosses the x-axis, and that's where y equals 0, or where f of x equals 0. So here, if you put 0 in for f of x, so this is at f of x, we put 0 in for f of x, sometimes you can factor this. Well, this one will factor. So x and x, 2 factors of a +5 that give us a -6, that'd be a -5 and -1. If we set each of those equal to 0, we get x equals 5 and x equals 1. So what that means is this parabola is going to cross the x-axis at 5 and at 1. So that would help you in graphing that. Sometimes if you want to find the x-intercepts, if it's in vertex form, you can do this. So we move the 7 to the other side. Now Since it's a squared, we can square root both sides. So if we square root both sides, we get that. Don't forget the plus or minus. Now we can just move the 3. So that would tell us our two x-intercepts. 3 plus radical 7, 3 minus radical 7. Sometimes you get one like this. Now it's a quadratic, so we want to get it equal to 0. So I'm going to move the 5x over to this side. Sometimes it won't factor like this one. It's not square rooted. So we might have to use the quadratic formula. So x equals negative b. Remember the quadratic formula is negative b. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b would be the opposite of 5, which is positive 5, plus or minus the square root of b squared, 5 squared is 25, minus 4 times a, which is 3, times c, which is negative 1, all over 2a, which is 2 times 3 is 6. So that's the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now to simplify, let's see, in here, 4 times 3 is 12, times 1 is still 12. That's going to be plus 12. So 25 plus 12, that's 5 plus or minus the square root of 37 all over 6. So those are your x-intercepts. You could approximate those. Square root of 37 is about 6. So that'd be 5 plus 6, which is 11/6, which is just short of 2. 5 minus 6 would be a negative 1, so negative 1/6. Graph those. Okay, 3 more. Here, they give us some information. It says we have a parabola. Its vertex is 1, 2. It goes through the point 3, negative 6. So we want to find the equation. Well, here's our general form in vertex form. We use that because they told us the vertex. Well, the vertex, that's our h and k. So let's plug those in. We can plug 1 in for h. We can plug 2 in for k. Well, then they gave us the point 3, negative 6. So that means when x is 3, the f of x, which is here, is negative 6. So we can plug those in. So now we have negative 6 equals a times 3 minus 1 squared plus 2. So you see all we did was plug 1 in for h, 2 in for k, 3 in for x, negative 6 in for f of x. That's all we did. Now let's simplify and see if we can solve that for a. So if we subtract 2, that'll be a negative 8 equals a times, let's see, 3 minus 1 is 2, squared is 4. So now if we divide by 4, a is negative 2. So our equation is f of x equals negative 2 times, here we knew h was 1, x minus 1 squared plus 2. There's our equation. So after we found a, we plugged it back into the original. We left the h and the k that we plugged in there. There's our equation. Here they tell us something about this. It says this is increasing from negative 4 to infinity, so we need to graph this. You can start anywhere you want. Actually, looks like maybe this is the line here. So let's see what we have. It passes through the point negative 2, 4. We know it's increasing from negative 4 to infinity. It has a range of negative 1 to infinity. Well, if that's the range, it's from negative 1, think about it, it's from negative 1 up to infinity. Doesn't this parabola have to open up? isn't its low point at -1? So K is -1 because the range is from -1 up. So K has to be -1. Now it's increasing from -4 to infinity. So if you think about it, think of a parabola. If it's increasing, it's only increasing here. So doesn't that mean our x coordinate has to be -4? So that's h. So we know h is -4, k is -1. We can do it just like we did the last one. Take that equation, let's plug what we know in there. We have f of x equals, let's see, I'll just write out that equation. So we know h and k, we know h is -4, we know k is -1. They gave us the point -2, 4, so x is -2, y is 4. So if we plug all those in, we have 4 equals a times -2 minus a -4 squared plus a -1. Well, let's see. -2 plus 4 is 2. -2 plus 4 is 2 squared is 4, so we could call that 4a minus 1. So if we add 1 to the other side and divide by 4, so a is 5/4. So now we go back to our equation. F of x equals 5/4 times x minus h. So x minus a -4 squared plus k, which is -1. So there's our equation. Now it says find it in standard form. Well, we need to do a couple of things. 3 things actually. We need to FOIL that out. So we need to multiply out the x plus 4 squared. So x times x is x squared. X times 4 is 4x. Twice is 8x. And then 4 times 4 is 16. So we have that. Now we need to distribute. So we distribute the 5/4. 5/4 x squared. 5/4 times 8 is 10x. And 5/4 times 16 is 20. And we still have a -1. So 5/4 x squared plus 10x plus 19. That's the equation of a parabola. Again, we knew that by thinking about these points. If it's increasing from -4 to infinity, that means that's the right side of our parabola. So the x coordinate of the vertex has to be -4. The range is -1 to infinity, so if it goes from -1 up, the y value here must be -1. That's our k. This last one we have given a table. Well, let's look at the numbers here, see what kind of a parabola we have. So we start off on the negative number, so from the left, notice we start with a big number and we're coming down. So isn't our graph decreasing here? 23, 14, 7, 2, -1, -2. Now notice it went -1 to -2 and then back up to -1. So this must be our vertex here. You see how it starts at 23 and it's decreasing till it gets to -2, and then it starts increasing again after that. So that's our vertex, is 1, -2. Let's see, it looks like here we went from 23 down, so here we are decreasing. Right from the left, we started at 23 and got smaller each time. Now to source here, we got all the way down to -2, and then we started going up again. So in here, it's increasing. I'm sorry, decreasing, sorry. No, that's increasing, my bad. Getting all myself all messed up here. So where is it increasing? It's increasing from, if this is our vertex, from 1 to infinity. Axis of symmetry is always x equals h, so x equals 1. Equation in vertex form, well, we know the vertex. We know lots of points. Let's plug that into equation like we did on the last two. So if we take that equation, let's substitute in. Let's see. We know h is 1. We know k is -2. We can use any of these points. It doesn't matter what you use. You can use any of them you want. Let's say I use 3, 2 just for the heck of it. So x is 3, y is 2. So now we have 2 equals a times 3 minus 1 is 2 squared, which is 4 minus 2. So if we add 2 to both sides and divide by 4, so that means if we plug that back in here, we have f of x equals a, which is 1, so we don't have to put that, over x minus 1 squared minus 2. So there's the equation in vertex form. Oh, and we already did the axis of symmetry. That's it for 5-1.